Okay, so the second part of the investigation looks at exponential functions of the form y equals b to the exponent x again, but this time where the value of b is between 0 and 1. So what that means is you might have values of b such as 2/3. Okay, that's an example of b where the value of b is between 0 and 1. So the ones that we graphed in the investigation looked at y equals 1/2 to the exponent x, y equals 1/3 to the exponent x, and y equals 1/4 to the exponent x. And you'll notice that the shape of the graphs are slightly different. Some graphs are more steep than the other. And you'll also notice that the graphs have changed direction versus what we saw in part A. So in part A, we saw graphs that went up and to the right. But in part B, we're noticing that when the base is between 0 and 1, the graph is coming down and to the right. So they're actually decreasing functions instead of increasing functions. Okay? We'll talk about why that happens in a couple of minutes. So, one of the questions you had to answer was, as x approaches negative infinity, what happens to the value of y? And you'll notice that this time the behavior of the graph is a little bit different. And so as I look at smaller values of x, so as it approaches negative infinity, as we get smaller and smaller, what's actually happening in this case is the value of the function is getting higher and higher and higher. So what's happening is, as x approaches negative infinity, the value of y is approaching positive infinity. As x gets smaller, y is getting larger. Okay, the values of y are becoming higher and higher. Okay, so for example, as I go from x equals negative 1, I get y equals 2, versus x equals negative 2, I get y equals 4, x equals negative 3, I get y equals 8. So as I make the value of x smaller here, the value of y is actually getting larger. Okay, so I just looked at the blue graph, y equals 1/2 to the exponent x, but it's true in all the graphs. Okay, the next question says, using this information and prior knowledge, what can you add to your graph? Well, this is kind of irrelevant to the previous question, and I apologize for that. But what I want you to think about is, as x is actually approaching positive infinity, what do you think is happening to the graph? And you'll notice that the graph is getting smaller and smaller and smaller and is approaching the x-axis, which is y equal to 0, but it never actually ends up touching the x-axis. And so what we can add there is a horizontal asymptote at y equals 0. So I apologize, the order of the questions are not correct, but hopefully you get the idea. There's still a horizontal asymptote at y equal to 0 here. Okay? The next question says, as x approaches positive infinity, what happens to the value of y? So, as x becomes larger numbers, what's happening to the value of the function? So, if we think about what's happening as x is getting bigger, we're going from x equal to 1, or to 2, to 3, to 4, to 100 eventually, 1,000, etc. What ends up happening is that the value of the function seems to be getting smaller and smaller and smaller and smaller and smaller, and it starts to approach y equal to 0. It never touches it, but it starts to approach it. Okay? So here we are again. As x approaches positive infinity, y approaches 0. So this behavior is actually opposite to what we saw previously. The value of the function is actually getting smaller and smaller and smaller. Okay, the next question asks you for the domain and range. Now the domain and range haven't changed. If you look at the domain, x does not have a lower limit. It can continue indefinitely towards the left. And it doesn't have an upper limit. It can continue indefinitely towards the right. So x is an element of all real numbers. In terms of the range, what's happening is that the function is actually only valid for values of y that are greater than 0. So again, all the values of the function are positive numbers only, so values of the function that are greater than 0. And so the domain and range is the same as what we saw previously. And the last part says, how does the graph of an exponential function vary as the value of the base decreases? So what that means is, as I go from a base of 1/2 to 1/3 to 1/4, how is the graph of the exponential function changing? And so if we look back up at the graph, we can see that as I make the base a smaller value, so 1/2 a third, and then a quarter. 1/4 is smaller than a half. And so as I make the base smaller, you'll notice that the graph is actually steeper. Okay? And so I want you to think about why that's happening. I know towards the right it's hard to see the graph, and that's because the values are so small that it's actually hard to actually picture what's going on there. But in terms of what's happening to the graph along here, think about what happens as you go from x equals -3 to -2 to -1. And let's compare the blue graph here to the green graph here. So let's say I plug in -2. So let's say I'm looking at y equals 1/2 to the exponent -2 versus y equals 1/4 to the exponent -2. Now I know with the negative exponent I write the reciprocal of the base to a positive exponent. So the reciprocal of that is 2 to a positive exponent of 2. And so I get a y value of 4. Versus if I do the same thing here, the reciprocal of 1/4 is 4 to a positive exponent, which is 2. And I get a y value of 16. What you'll notice is, even though this base is actually smaller, for negative values of x, as soon as I write the reciprocal to a positive exponent, what this ends up creating is a larger base than the previous question. So the reciprocal of a small number is a really large number, and if you apply an exponent to it, you end up getting a much larger number as a result. So what happens is, to answer the last question, how does the graph of an exponential function vary as the value of the base decreases? The graph of f of x gets steeper since the rate at which the function decreases is larger. Okay? So what that means is, if you actually look at the graph, so let's just focus on the graph, you'll notice that the graph of y equals 1/4 x is actually getting smaller much faster than the graph of y equals 1/2 x. Here it's getting slowly, it's getting smaller. But here, because the graph is so steep, it ends up decreasing in value much faster.